my name is Matisse Fields, and today I'm going to explain how to build a fixed dome biogas plant, as well as draw out a diagram of how it should look. In this video, we will also discuss what a biogas plant is, what is the biogas plant working principle or mechanism, how to determine the plant size and average daily feedstock, how to find the appropriate size of the digester, what elements are required for the design of a biogas plant, and the materials required for construction of a fixed dome biogas plant. A fixed dome biogas plant is an airtight underground tank in which organic materials are mixed with water, are digested or fermented through anaerobic bacteria action in the purpose of generating biogas fuel. The treated waste is a nutrient-rich and nitrogen-rich fertilizer, while the biogas is a flammable gas composed of methane, carbon dioxide, hydrogen, nitrogen, and hydrogen sulfide. The main components are methane and carbon dioxide, and other gases are in the form of traces. Biogas plants are a preferred alternative to burning dried animal dung as a fuel and can be used for the treatment of human waste as well. Biogas typically refers to a mixture of different gases produced to the breakdown of organic matter in the absence of some oxygen. Biogas can be produced from regionally available raw materials such as recycled waste. It is a renewable energy source that causes very little pollution. The biogas plant works on the principle of fermentation, where the bio-waste is digested to give methane gas. The major components of the biogas plant are a digester tank, an inlet for feeding the waste, a gas holder tank, an outlet for the digested slurry, and the gas delivery system for taking out and utilizing the produced gas. The size of the biogas plant depends on the quantity, quality, and kind of available biomass, average daily feedstock, and expected hydraulic retention time of the material in the biogas system. The most important part of this step is to determine the size of the digester. The size of the digester, that is the digester volume, VD, is determined on the basis of the chosen retention time and the daily substrate input quantity, SD. The mathematical equation for finding the volume of the digester is shown here on the screen. Here, the VD is the volume of the digester. SD is the substrate input quantity, and RT is the retention time. The retention time is determined by the chosen or given digested temperature. For an unheated biogas plant, the temperature prevailing in the digester can be assumed as 1 to 2 degrees Kelvin above the soil temperature. For a plant of simple design, the retention time should amount to at least 35 days. The mathematical equation to find the substrate input quantity is shown on the screen. In most biogas plants, the mixing ratio of dung and water amounts to 1:1. The biogas plant consists of the following: an inlet tank, digester vessel, dome, outlet chamber, compost pits, inlet tank or mixing chamber, a digester vessel or tank body, an outlet chamber or expansion chamber, or a compensating chamber. If the materials used in the plant construction, such as cement, sand, aggregate, etc., are not of good quality, the quality of the plant will be poor even if the design and workmanship are excellent. The fixed dome biogas plant should be constructed with stones to form the round wall of the storage of slurry. The outlet dome, on the other hand, needs to be constructed with plain concrete slabs with reinforced concrete, while the inlet of the plant needs to be constructed with either stones or bricks. Let's move on to the live drawing of a fixed dome biogas plant diagram.